Okay, let's go ahead and take a look at this particular function that we're going to look at called the simple rational function, or the reciprocal function. Okay, and this is basically what it looks like. It says p of x is equal to 1 over x, where x of course cannot be equal to 0. Okay, one of the things that we're going to see is that once we go ahead and apply transformations to this particular function, parent function, then what happens is that the way that you can express it can actually look like this. Okay, so what we want to do then, which is going to be key in what we've been trying to do in terms of determining how parameters are affecting the parent function, is we need to go ahead and actually look at this as another form of the reciprocal function, or the simple rational function in disguise. Okay, let's go ahead and take an example, and I think you'll understand exactly what I'm getting at. Now let's go ahead and take a look and say, for example, that our function is -3 over x minus 1 plus 4. Now I'm hoping that everybody will be able to recognize that this parent function, which is 1 over x, is actually in here, and then we're just doing transformations to that particular parent function. So I wrote it in a slightly different way so that we can see it step by step. Of course, this means that we actually have to move we have a shift to the right 1 unit. We take the parent function, we shift it to the right 1 unit, and then after that we flip it, right? Reflect it about the x-axis, and then we have to stretch it by a factor of 3, and then after that we have to move it up 4 units. Okay, so hopefully everybody can see that if you have it written similar to this form here, then all the principles of transformations dealing with dependent upon the parameters is consistent, okay, with what we've been doing before. The thing though is that oftentimes you'll see it in this form. Now, how do you get it into this form? Well, we just need to go ahead and find a common denominator. In this case, the common denominator would be x minus 1. So I need to multiply the 4 by x minus 1 divided by x minus 1. And now I got a common denominator, so now I can actually go ahead and simplify the numerator to come up with 4x minus 7 divided by x minus 1. Now, if you go ahead and you take a look at this form, of course, is much more difficult to figure out what you do to come out with the parent. It's hard to determine what the parent function is, first of all, and then it's also very difficult to determine what transformations create the child function. So the key then is to just make sure that we realize that if we see something that looks like this, in this form here, it's really this. But we need to get it so that it looks like this so that we can apply all the rules for the parameters and transformations to be able to come up with a reasonable graph. So let's take a look at an example as to how to do that. If we go ahead and start off with f of x is equal to 2x plus 3 over x minus 1, notice it's very similar to what we have here. Okay. Now the way that we need to do that is we need to actually go ahead and incorporate or introduce the same factor, the same binomial factor denominator into the numerator. So I'm just very simply going to just put 2 times by x minus 1. Okay. After that, I just need to go ahead and determine what constant I need to add to that in order to make sure that I come up with 2x plus 3. So if I take a look at this, this is 2x minus 2. Well, in order to get plus 3, I have to add 5 to that. So notice that this equation here is exactly the same as this equation here. It's just that the form is slightly different. Now once we get that, then we can break this up into 2 rational parts. And then, of course, we can cancel out the x minus 1 here to come up with this form here, which, of course, is much easier to see in terms of what the parent function is and what transformations are actually being applied to that parent function. So there you go. We start off with the reciprocal function here. We need to recognize that this form is just another form of the parent function in disguise, the rational parent function in disguise. And the algebraic method by which we can get it to this form here is to introduce this denominator binomial into the numerator so that we can simplify to something that's recognizable to us. Okay? So give it your best shot. We'll see how you do, and we'll talk about some examples in class. Okay? See you. See you later. Bye-bye.